Hello out there, welcome back once again. So our focus today, we'd like to do some revision, focus on correlation and regression model. Okay, let's see what we have for you today. Okay, so I'll encourage you that while we're doing some revision, especially the focus is on problems. I'd like you to try some of the problems with us. Have a piece of paper, have a calculator with you. It's not really good just to observe without trying the problems. Okay, I really encourage you to try at home. It's not about observing. To be successful in maths, it's about practice, practice, practice. And please try with us. Okay, fantastic. Let's see what we have. So, under correlation, okay, we'll look at, we know there's a line of best fit. Okay, the line of best fit and the least square regression, then correlation, linear regression, and interpolation and extrapolation. Okay, very important. I would like us to look at some of the terminology, the keywords. Correlation coefficient. What do we remember about correlation coefficient? What we know is that correlation coefficient is between -1 and 1. And correlation coefficient measure the correlation between two variables, the association between the two variables. Okay. For example, I might measure your maths marks versus your science marks. Does it mean if I have a good maths mark, I'll do well in science? Is there a correlation between the two? Okay. And what we need to remember about correlation also is that a correlation of 1 implies there's a perfect correlation. That's the strength of correlation. A 0 correlation, there is no association between the two variables we're studying. Okay, are we together? So correlations from weak, medium to a strong correlation. Okay, and we can do that using our calculator. Okay. And what about the least square regression? So the least square regression, we can do the least square regression using our calculator. It's actually the equation of what? Of the line of best fit, which is the least square regression, which is more a straight line, which is this form, y equals to a plus b x, which you can do using our calculator. Are we together? That's the least square regression. Then extrapolation. Now, we have our least square regression, or the best line, the best line of fit. Now, when we want to predict or we forecast, if we predict outside the range of the data, we are extrapolating. And what does extrapolate really mean? If we're predicting outside the given range, the reliability of the prediction is not really that strong. Okay? That's when we extrapolate. We don't, it's too dangerous to predict outside the range, because we don't know the behavior of the pattern after the range. Okay. And what about the interpolation? The interpolation also is when we forecast, we predict using the least square line or the regression line. But interpolation is when we predict inside the range. And what is nice about the interpolation is that when we predict inside range, that's really good. We can rely on the prediction. We can trust that prediction without the range. The extrapolation, no. Okay, it's okay, but the reliability is the most important. Okay, because you can predict something and might not happen. Okay, currently people have predicted the third wave using previous data. Is that really happening? Might be wrong because of the prediction. Okay. Are we all together? Because we're kind of actually extrapolating, because we're using data And we're predicting that. Are we all together? We're extrapolating. Good. So, what we said, we're going to look at questions, okay? Application, because we know what is correlation, we know regression line, we know the line of best fit. And the line of best fit, remember, it must pass through the mean. Okay, good. Now let's look at our first question. Okay, and when you do your question, very important to read thoroughly and ensure that you're answering the right question. Sometimes we want to answer the questions, but we're answering the wrong questions because we're not reading the question. Okay, let's see. There's the question. So the manager of a hardware store records the number of staff that are in the store on a given day, as well as the sales generated per day. Are we together? So this is a store manager. So you have a staff, people working for a hardware, and how many sales and rents. How many sales they make. So here we had a day where there was 20 staff members, and what about the numbers of sales? Was 35,200. Are we together? And there was a day, only 5 staff members, but numbers of sales, 9,200. So that's the data. We read the question, we understand the question that it's a manager. What do you want? What do we have now is the staff members at work and numbers of sales. So our independent variable here is a staff member, numbers of sales. Let's see now. We understand the question. Now we go further. So the first question is, calculate the correlation coefficient for the above, then comment on the strength of the relationship. Are we together? So there we have the data. So what we have to do is to put the data in our calculator and calculate the correlation. Let's see how we do that. Okay. So there we have a calculator there. I already have my data. You can see my data there. So 20, I've put the data, 20 staff members, we have what? 35,200. And we have 5 staff members, 9,200. Okay, how we put our data? We put our data using the mode, then the table function. After that, we say AC. AC does what? Stores the data. Are we together? Then shift 1. Then we select regression 7. Then we want what? We want R, okay, which is 3. Put 3 there. Equal. Then we get, let me run my correlation to 3 decimal places, then any instruction, very important. Okay. If R is, let's go back there. R is 0.9, let's see that, 0.975. That's the correlation. We calculate using our calculator. Okay, you put your calculator in state mode, you get a table, put all the data, AC to store what? To store what? The data, then shift stat 1. Are we together? Then you're able to select R for correlation. So we get a correlation of 0.975. What does it mean? This is a strong correlation because this is close to 1. This is strong correlation. Okay. There's a strong correlation. What does it mean? So it implies the more staff members at work, the more we have number of sales increase. There's a strong correlation between staff and sales and rent at the store. Are we together? Then as a manager, what does it mean? So it implies that if you have high staff members, will be profitable for this business? Are we all together? Okay, based on this correlation. Okay, fantastic. Are we all together? A strong correlation for that. Now, let's look at the next question. So the next question is, find the equation of the line of best fit in this form. So the equation of a line best fit is what? Is our regression model. Are we together? Let's see. We're going to use our calculator. We've already inputted our data in our calculator. There's no need to do it again. Okay? We just have to check the data. Let's look at that using my calculator. So if I say, okay, if I say AC, shift 1, are we together? I can select 2 to check my data again. If I 2, there's my data coming back again. Are we together? I don't have to put it again. My data is my calculator. So AC, okay, shift 1. Are we together? What am I trying to do? Let's look. We're trying to find the equation of best fit. Regression. I select 7. 7. 7, I need the A value. Are we together? I put 1 equal. What is my A value? So my A value, let's put my A value. A value is equal. Let's check again. A is 2788. 2788.26 if I round to 2 decimal place. 26. And what about the B value? The B value, still using my calculator. So the B value, I can go shift 1 again. Regression 7, and I want the B value, which is 2, equal. There's my B value, which is 158. 1, 5. Let's see again. 1658. So 1658.39 if we round to 2 decimal place. 39 if you round to decimal place. Are we together? So if you look at this, where's this regression? Let's look at our calculator again, because if we do that, so it's actually mode stats. So you're trying to find that. Can you see A, Y equals to A plus BX? Are we together? So we know that Y is A, BX. And we already have our A and B. What is our A? Is 2788.26 plus B is 165.839x. So that's our regression. So we did find the equation of the regression. And I can use this to do what? To forecast, because X is staff, numbers of staff members. Okay. If I want to know the number of sales, if I have 6 staff members, I can use the regression model. Okay. Let's check our next question. Now, the manager, so we still have the same data. So the manager decided to use 19 staff members in his store. Okay. At the end of the day, this sale, okay, he used 90 staff members. At the end of the day, the sales is at 23,000. Will the manager consider this a successful day? Explain the answer. So the manager uses 19 staff members, and he gets 23,000. Is that good? So what we have to do is to use our regression model and use X as 19 and see what is the Y value. Are we all together? So we have our regression model in the previous page. Let's see, we can go back, use it from there. So we have our regression model there. Let's use that Okay, so I'm going to use my calculator. While I see X, I'll put what? 19. So let's use our calculator. Clear everything. So it's 2788.26 plus 165.8.39. What is my X value? Because the manager wants to use 19 stuff. So we get what? 34,000 something, above 34,000. But now, the manager used 19 and got what? 23,000. And what do we get? We get 34, 3. Okay, let's fix that. So we get 3, 4, what? 3, 4, 297. 297.67. 67. So we used our regression. Where we see X, we put 19. This is what we get. That's the expected. Using the regression model, the sales for using staff members should be 19. But the manager got 23,000. Was this a successful day? No, this was not a successful day. And especially because we are interpolating. Remember we spoke about interpolate. I'm predicting inside the range. So the prediction for this, I can rely on the above 34,000. That the expected for using staff members should be above 34,000. But the manager got 23,000. This was not a successful day. Okay, guys. Hope to see you after the break with more questions. And I hope to see you ready with your calculator and you're working on some of the problem with us. See you shortly.